wrong division. I was in a division that was full of mechanical and propulsion engineers. I was a mathematician. There was a computer there, but I couldn't use it. They wouldn't, I mean, the NASA people weren't allowed to use these things. We supervised contractors to use them. So it wasn't a very, I mean, I didn't do anything except watch other people do things. But anyway, here we go with the NASA trip. This part in white, as you see, is the Kennedy Space Center. The green part is the Air Force Station. This is Pad 39, where the Apollo launches were made. This is the Vertical Assembly Building, which at that time was the largest building volume-wise in the world. The Saturn, as you know, is the one that took us to the moon, the Apollo project. I worked on the Saturn I, and I left before these others started. But the Saturn I was just a test vehicle to test and make sure the first stage rockets were working and the fourth stage were working good. Saturn I was here, Saturn 1B added a couple more pieces, and then Saturn V is the one that went to the moon. Let me tell you, I don't know if any of you have been down to the Cape during the launch, but it's quite a sight. But the Saturn V was the biggest of all. My house was 25 miles from the Cape. When the Saturn V took off, my plate glass windows were up like that. I mean, it was astounding machine.
What was the propulsion for the fuel?
I'm sorry?
What was the fuel for those rockets?
Kerosene and oxygen. Kerosene and oxygen. I believe, except they call it JP4 or something like that. I worked at NASA. I worked for the Guidance and Navigation Division, which was headed by a man named Dr. Yenke, who was one of the German scientists, along with Werner von Braun, that were brought over to this country to develop our rocket system after World War II. The only thing I really did here was we were using an RCA 110 computer, which you never heard of. They didn't last long, and RCA got out of the business pretty soon after that. But the RCA was used to control the launch phase of the vehicles. Unfortunately, it wasn't very easy to use because there was very little input. Paper tape was the only way to get in, and there was no high-level language involved. You had to write everything in machine code. So I said, why not? We had a 635, a GE 635 on. I think I've got a picture. Yeah, there was a GE 635, which was architecturally very similar to the IBM machines, the IBM 7190. I suggested that we write software on here, a translator, which would translate from a high-level language, a source language, into machine code for the RCA. And I believe they did that, although I left before it happened. Yeah, okay. And then one other thing I did there, Goodyear, the people that make tires and blimps, built a parallel processing machine. This was, I think, one of the first possible around. It had, unfortunately it didn't get off the ground, but I was suggesting that we use it for the launch phase control system. But it had, as you can see on the screen, 4 by 256 1-bit processing elements, 1 bit. So they could do a lot of things at the same time. And it was coded so that one instruction would do an operation on a lot of sites. You'd send it one instruction, and that instruction would be executed on every processor. There was a way to say, don't do it on this processor. So you could eliminate some because you didn't mean the instruction to do what it was doing that way. But I went to a course on this up at Akron, and they were developing it primarily for air traffic control. I know you've all seen the air traffic control consoles where they have a great big screen and they have little dots representing airplanes, where they're going and all of that. And so to show how good this machine was, they ran a simulated version of air traffic patterns on the machine at normal speed, which it did fine, and then they speeded it up 100 times real time. So this machine was able to handle 1,000 airplanes at 100 times real time. So it was really good, but unfortunately they didn't succeed in preserving it.
So commercial air traffic would, commercial air, was like, would working at the same time, on the same things that y'all working on. So y'all borrowed a lot of stuff from there.
Not really. I don't actually know what air traffic control was using at the time. I'm sure it was old. This was in the 60s, early 60s. So whatever air traffic control units were using was probably very dated. The most up-to-date machines were at Lawrence Livermore Lab or MIT or some places like that. And they were building, actually, one of the most impressive machines was the Stretch machine, which was an IBM, which was used for weather control, weather forecasting. But I don't think we traded things with the air traffic control people much. Okay. After NASA, I went with a company called DVA Systems, and I was there about 16 years, so I had a lot of interesting experiments here. First, we'll look at the computers that were available there. Our in-house computer was an IBM 620, and I'll show you some pictures of these later. Then there was a Scientific Data Systems 910, which was later bought by Xerox. Control Data's 3100 was a mini computer, not mini in the sense of today, but mini back then, that was a 24-bit machine, and it was dedicated, the processors were dedicated to either commercial use or scientific use or whatever. Then there was a small machine that Hewlett-Packard built called a 2100, and it was a very good. Hewlett-Packard had a tremendous reputation back then. I have some problems with them today, but at that time they built quality equipment, and they were doing a lot of work in the medical field. So that was a good thing. The Burris 3500 was a commercial machine that basically ran COBOL. They claimed they had a Fortran compiler, but as far as I know, it never worked. Then we used an IBM 7094 for a special purpose and another GE 635. And then finally, I was able to go back to Florida State to do a run on a CDC 6400, which was really a fine machine back in that time. This is a picture of the 1620. It was the first machine I know that had a variable word length, and it did use bytes. You could code to the byte level instead of a word level, but you could make your word as big as you wanted. So if you wanted quadruple precision, it was easy to do. You just formulate the words that way. And like a lot of others at that time, most of the input was punch cards. They did have a small disk drive. I think it was about 5 megabytes. And one interesting thing they did that people kind of laughed at, instead of using dedicated addition circuitry, they used tables to do addition. And I don't know exactly how that worked, but it wasn't very sophisticated. Again, no operating systems. The cards that you punched in had little codes on them that would allow the computer, or would tell the computer to run this process or that process or whatever. It did have an assembly language, a Fortran, and a Gotran, which was sort of like BASIC, I think. I didn't use that. The Scientific Data Systems 910, I couldn't find any pictures of it, was a pretty good machine. I went to a software training course on it in Santa Monica, California, and the best part of that was after the course was over, they took us to the Pink Pussycat for a celebration. You don't know what a Pink Pussycat is. It was a nice club. Back then, Snow White, which is IBM, and the Seven Dwarfs, RCA, Univac, GE, Honeywell, CDC, Burroughs, and NCR, had all started and started their machines. SDS figured we can do better than that. So they built these new machines that were very cheap in price and worked quite well. We used them in a number of places, and they were really quite good, easy to work with.